System, Chapter 2, that is Architectures. To start with, what is architecture or software architecture? The organization of distributed system is mostly about software components and that constitute the system. The local organization of a distributed system into software components refers to as software architecture. So this is the highlighted line that is the logical organization of a distributed system into software components is referred to as software architecture. Okay, so combining different software components together into a distributed system is called software architecture. So architecture style, that is what kind of components are there, the way they are connected, how the data is exchanged between these components and how they are configured. Okay, the first is connector, a mechanism that mediates, communicate, coordinate or cooperation among components. Examples: remote RPC messaging. You'll know what is RPC, but you might have learned in RPC networking, that is remote procedure call. Okay, now architecture styles, there are different type of architecture style. One is layer architectures, service oriented architectures and publish subscribe architectures. Okay, the first we'll learn is layered architecture. The basic idea for layer architecture is simple. Components are organized in a layer fashion where components at each layer make a down call to the component at the lower level. So if a component is here, it will call the lower component. It's like a hierarchy. Okay. So if you see here the diagram, see layer n minus 1, 2. So it starts from here and the topmost layer will call the layer below it, then the layer below, and so on and so forth. Okay. So there are different types of layer architecture you can see here. Layer n minus 1 can directly call n minus 3 or n2 can call n3, like different. That is called mixed layer organization. So first we have pure, then mixed, and then layer organization with up calls. Up calls means the layer below can also call the layer in the top. That is called up call. Okay. The next we have communication protocols. So this is an example. So well known our layer architecture is there of a communication protocol stacks. So if you see a communication protocol, see layer 1 is calling layer n minus 1 and that is the interface. This is the interface that allows n to call n minus 1 and it can call either this side or this side also. Party A can call party B. That is called a service and the protocol that helps in communication. Okay. The next we have example of communication protocols. In communication protocol stack, each layer implements one or several communication services allowing data to be sent from destination to one or several targets. Communication protocol describes the rules that parties will follow to exchange. So is protocol means whatever for like protocol. The term protocol means what kind of rules we need to follow to do something. So here communication protocol means what kind of rules do we need to exchange information. Okay. The next, application layering. There are three different types of application layering. One is traditional three-layer view. So application interface contain units for interfacing to users or external application, a part that handles interaction with user or some external application. Then processing layer, then data layer. Processing layer will process whatever data is coming, is also called the middle part or middleware if you know. And then data layer. Data layer is like, for example, you can call a database. So if somebody asks, you'll go to processing layer. Okay, this data is asked, so you should be handling data from this database, and it will call the database. The database will provide the information what the client wants, and it will send it back to the client. Okay. If you see here example, a search engine. So this is the user interface, that the web page, and you are asking, there is a query generator that is in the middle. We can't see that, and it will go and ask the database that is keeping the information, and it will, after getting that, it will rank an algorithm. So which is the top search, it will come at the top, then it will generate the HTML and it will send it to a user or the client or your desktop, right? The next, we learned that internet search dedicated by buying houses. Then service oriented. So service oriented is my object based architecture, microservices architectural style. So basically nowadays microservices are used the most, right? So microservice architectural style. Then coarse grained service composition, resource based architectures. In that, first we'll learn object-based architecture style. Although the layer architecture style is popular, one of the major drawbacks is the strong dependency between different layers. These potential dependencies should be careful considered while designing communication protocol stack. So what they are saying is the different layers are dependent on each other. So what will happen if one layer stops working, then the other layers below it will stop working. So to remove this, it is one of the major drawbacks of layer architecture. So we move on to service oriented. So one is object based architectural style. Direct dependencies to specific components had led to architectural style reflecting a more loose organization to collection of separate independent identities. Whether they are called services or microservice, we know microservice basically you have learned in web development. So microservice is one of the most common term and mostly it is used nowadays. Microservice, for example, login in, etc., etc. As you go on, we'll learn it. So if you here see, you can see different objects are here. Different objects are different functions that has method call and it can call from one object to another object. So they are independent of each other. So what happens if even one object stop working, it can the object can other objects can work on because it doesn't have any dependency on the object that has that is not working, right? So if you see here, object-based architecture provide a natural way of encapsulation data that is called object state. The interface offered by the object conceals the implemented details and enables an object directly independent of its environment. So see, this is the interface, the whole thing, the state, and there are the different methods. So it can independently, it can access whatever data. It doesn't have to be dependent on other interfaces or layers. So to get the information. So that is what I was saying. Then object, we have the diagram here. So if you see here, network is there from client OS proxy, same interface as the object. It will have the client invokes the method, it can directly access the proxy, right? So a common aggregation of a remote object is the client side proxy. So client side, this is the client side proxy. We also have server side proxy. So when a client binds to object, distributed object, implementation of this object's interface called proxy is then loaded into the client address space. A proxy is analogous to a so-called client stub in RPC system. The only thing it does is pack method invocation message and unpack reply message to return the result of the method invocation of the client. So basically it's saying is this allows the client to send message and unpack reply messages. It is result of the method invocation by the client. Okay. Then microservice architectural style. So each microservice is under separate network process. The implementation microservice could be in form of remote object. There is no common agreement on the size of such service. There can be thousands of microservices running. There is no agreement on what the size of the service should be. Then a microservice represents a separate independent service. Modularization is the key to designing microservice. So modularization means modularity. That means each component is independent, that we can take it out. For example, functions, right? We are building different programs, but the same function is used in different functions. So what we can do, we can create a file that can be imported, like we import, right? For example, pandas we don't write it, right? We just install and import. So that is called modularity, right? Okay. While SOA and microservice share similarities, modularity and loose coupling microservice are more granular evolution of SOA, focusing on small independently deployment components. Microservices are often built with the need for an enterprise service bus, that is ESB, featuring lightweight protocols like REST, most commonly used REST APIs or protocols, we know RESTful APIs we call it. A messaging quiz like RabbitMQ for sending messages in and out. So example of microservice, we know that micro storage, payment, shipping. For example, payment is different microservice, that is, for example, razorpay. We know razorpay is like a microservice. We just use the API and we can incorporate in our, we don't need to code the whole payment thing. It's already there, we can just incorporate. So it is modular, and that is example of microservice. So it's a different entity. A distributed system is a huge collection of resources that are individually managed by components. Resources may be added or removed by remote. So we can add or remove. So there are different operations. So if you have done web development, you will know that that is put, get, delete, and post. There, these are the four, and other also there, but we are just the main: put, get, delete, and post. So Amazon's simple storage service is one example. Buckets, if you know buckets, so it's a way of Amazon. This is example of Amazon web service, AWS. Okay. Then Amazon S3 soap. So S3 is type of storage system. If you see here, if you not given here, so it's a storage system. So Amazon S3 bucket list. So SOAP interface by now deprecated means is not there, but they have now different standards came, but these are old. So it used to exist. Okay. Then the SOAP interface consists of approximately 16 operations listed in the above table. However, if you were to access Amazon S3 using the Python Boto 3 library, you would have more than 100 operations available. In contrast, the RESTful API or interface offers only few operations. How? So SOAP import bucket, bucket create, my bucket. RESTful put the link, right? So it is also done simplification. So it is easier than RESTful API. SOAP interface. Then publish and subscribe architecture. So basically this is used in IoT. If you remember IoT, so one person will publish, it will keep on emitting the sorry, it will keep on emitting the value, and some other person or some other service will subscribe, so it will continuously. So in this model, coordination encompasses the communication and cooperation with process. It is from the glue that binds the activities performed by processes into a whole. Okay. So as system continue to grow and processes can more easily join or leave, it becomes important to have an architecture where dependencies between the process become as loose as possible. For example, publish subscribe, you can see as like a YouTube channel. A YouTube channel is there, you can easily subscribe, and when you want notification, for example, you don't like the channel, you can desubscribe or you can unsubscribe from the channel, and you will not get the notification. So it's very easy, instead of adding you manually, you asking requests. So that is what he's saying, that dependencies between process becomes as loose as possible. Okay.